Um, Last we discussed that I is equals to epsilon 1 upon r1 plus epsilon 2 upon r2 upon 1 upon 1 plus capital R upon r1 plus capital R upon r2, and that is for the parallel connection. Now we are going to simplify this equation taking LCM of r1 and r2. So we will reduce to the equation epsilon 1 r2 plus r1 epsilon 2 upon r1 r2 plus capital R r2 plus r r1. Considering r common, we are going to have an equation that I is equals to epsilon 1 r2 plus r1 epsilon 2 upon r1 r2 plus capital R r1 plus r2 in the bracket obviously. Now if we are going to divide this equation by r1 plus r2, what is going to be there? That I is equals to epsilon 1 r2 plus epsilon 2 r1 upon r1 plus r2 divided by r1 r2 divided by r1 plus r2. So r1 r2 divided by r1 plus r2. Separately for it, r multiplied by r1 plus r2 upon r1 plus r2. These r1 plus r2, these r1 plus r2 cancel. So we can say that our equation for the current has been reduced to I is equals to epsilon 1 r2 plus epsilon 2 r1 upon r1 plus r2 upon, we are considering capital R first. So capital R plus r1 r2 upon r1 plus r2. We are going to consider this as epsilon equivalent and this as r equivalent. So we will reduce to the equation I is equals to epsilon equivalent upon capital R plus r equivalent. So for the parallel connection, epsilon equivalent is epsilon 1 r2 plus epsilon 2 r1 upon r1 plus r2, and r equivalent is equals to r1 r2 upon r1 plus r2. And for the series connection of two cells, epsilon equivalent is epsilon 1 plus epsilon 2 and r equivalent is equals to r1 plus